For about 500 years, we've been obsessed with one thing: making things on rails go faster and faster. It's a story that starts with, believe it or not, just muscle and wood, and it takes us all the way to vehicles that literally float on air. This is that incredible story, the race for speed. So let's start this story right at the finish line: 603 kilometers per hour. That is over 370 miles per hour. And no, that's not a plane we're talking about. That's the record speed for a train. It's a number that would have sounded like pure science fiction just a couple of generations ago. So, that's the big question we're going to dig into, right? How did we possibly make that colossal leap from these simple little carts being pulled through mines to levitating metal pods that could actually outpace a small airplane? It's a 500-year journey of some of the most amazing human ingenuity you can imagine. To find the answer, we have to go way back. Before steam, before electricity, all the way to a time when all the power you had came from muscle, and the tracks themselves were just made of wood. And here it is, the humble beginning of it all. We're in the 1550s, deep inside these German mines. The problem was pretty straightforward. How do you move huge amounts of really heavy ore? Well, the solution was these things called hunt carts, pulled by horses or people along these basic wooden rails. This wasn't about speed at all yet. This was about pure, practical, raw power. Now this right here, this was the first huge upgrade in the story of the railroad. Wooden rails, they were a great idea, but they splintered, they wore down really fast. So by the 1790s, we get the switch to iron. And iron rails were a total game changer. They were stronger, smoother, and they could handle way heavier loads. This one simple change in material was the critical step that set the stage for a revolution. And that revolution, of course, was steam. And let me tell you, this was not just another upgrade. This was a fundamental shift in how we thought about power. This is the moment the train goes from being a simple tool for miners to a global force powered by nothing more than fire and water. So how did it even work? Well, in a nutshell, you burn fuel, like coal, to boil water in a big, sealed boiler. This creates an immense amount of steam pressure. That superpressurized steam is then funneled to push pistons back and forth, and that motion gets turned into the rotation of the wheels. It was this brilliant, powerful machine that converted heat into motion, creating the iron horse that would define an entire era. And just look at how fast things took off. It's incredible. In 1804, Richard Trevithick proves a steam locomotive can actually work. Just 21 years later, boom, the world's first public railway opens. And then a mere 5 years after that, you could buy a ticket for a scheduled passenger train. This wasn't a slow burn, it was an absolute explosion. A railway mania swept the globe, and tracks started connecting the world like never before. But for all its raw power, steam had its problems. The locomotives were dirty, they were really inefficient, and they took a lot of work to operate. So as we entered the 20th century, engineers started looking for something new, something better. And two big contenders emerged to take over from steam. First up was electricity. As early as 1879, Runar von Siemens showed off an electric railway, and by 1890, it was already powering London's first tube lines. It was just perfect for cities, clean and quiet. But for the long-haul routes, diesel became king after World War II. It wasn't quite as clean as electric, but it was way more efficient and a whole lot cheaper to run and maintain than those old steam engines. Okay, so with these new, more efficient ways to power trains, a whole new ambition started to take hold. The challenge wasn't just about hauling heavy stuff anymore. Now, it was about raw, unadulterated speed. The train was about to enter a brand new race, and this time, its main competitor was up in the sky. And this is the moment everything changed all over again. In 1964, just in time for the Tokyo Olympics, Japan unveiled the Shinkansen, what the world would come to know as the bullet train. Running on its own dedicated high-speed tracks, it hit 210 kilometers per hour. This proved, once and for all, that rail could be a modern, fast, and seriously efficient alternative to flying between cities. The age of high-speed rail was officially here. Of course, engineers are never satisfied, are they? As speeds got higher and higher, they started running into a fundamental problem, a law of physics, really. The new enemy wasn't a lack of power, it was friction. Just that simple physical contact of a steel wheel on a steel rail. So the next question was as logical as it was audacious. What if you could just get rid of friction entirely? The answer sounds like it's straight out of science fiction: magnetic levitation, or maglev. The basic idea is to use incredibly powerful magnets to literally lift the entire train up so it just floats on a magnetic cushion. No wheels, no physical contact, which means virtually no friction.
So how does this magic actually work? It's pretty genius, really. Step 1, you put powerful magnets on both the train and the track, or guideway. Step 2, you arrange those magnets so that the same poles face each other, north facing north, which creates this powerful force that pushes them apart and lifts the train. Then, step 3, a completely separate system of magnets creates this shifting magnetic wave that pushes and pulls the train, propelling it forward. It's like this elegant, frictionless dance of physics.
And you might be thinking this is just a cool concept in a lab somewhere, but it's not. Since 2004, the Shanghai Transrapid has been a real commercial train, zipping people from the city to the airport at incredible speeds. It's the living proof that this futuristic technology is very much a reality. So, where does the race go from here? Well, the hunt for more speed isn't over, but now it's joined by another, equally important mission: sustainability. The next big frontier for trains is about being both ridiculously fast and environmentally clean. And there are two main technologies leading that green charge. First, you have hydrogen fuel cells. They basically act like a power plant on the go, combining hydrogen and oxygen to make electricity, and the only thing that comes out is water. Then you've got massive onboard batteries, which store up renewable electricity right from the grid. For both of them, the goal is exactly the same: achieve net zero carbon emissions and create a truly sustainable way to travel for the future. But what about the absolute bleeding edge of speed? The most ambitious idea out there right now is the Hyperloop. It takes that maglev idea of getting rid of track friction and then adds another layer: getting rid of air resistance. The whole concept is to have these levitating pods travel through sealed, low-pressure tubes. By sucking out almost all the air, these pods could, in theory, hit speeds well over 1,000 kilometers per hour. And all this brings us to one last, kind of mind-bending thought. The entire history of the train, from wooden rails to iron tracks to magnetic guideways to sealed tubes, it's all been about perfecting the surface that it runs on. So the ultimate question has to be, what's next? Will the train of the future even need a track at all? It's a pretty wild question, and it just goes to show you that this 500-year race for speed is far from over.